So we're just going to continue with the storage technologies. Yeah. Yesterday we've seen different indicators before you could get your storage, before you know which storage you need to use for your when you want to get a disk or servers. What do storage mean, and how do you actually use them, right? So we spoke about the disk capacity, the rotational speed, the average access time, and the data transfer rate, as well as the input-output operation per second. And we've described what those terms mean. Okay. So today we're going to continue and see different architecture of storage and how they work together, how we can actually have a network of servers and storage in order for us to actually have a way of dealing with our data. All right. And remember yesterday as well, we spoke about the difference between megabyte and megabit. So that is very important that you know that, so that you understand whatever we're dealing with units, you know that when we're talking about the speed of the rate of the internet, of how the connection is, we're talking about megabits per second. But when we're talking about storage or data being transferred, we're talking about megabyte per second. All right, so today we're going to start with the storage networking type, the type of network that can be created for the storage. So we call them storage networking type. So what is storage networking type? So we need to understand, first of all, we understand that storage networking is just how we can, how storage devices are connected to servers. So we basically have many devices that can be connected to the server. So we have, for example, here we have many disks, a disk array that we connected to the server. So how these storage devices are connected to the server and the client, right, is what we call a storage network. Okay, so that's what we call a storage networking. So when we talk about storage networking, you need to know we're talking about how storage devices are connected to servers. Okay, so this can be a direct connection. It can be a local connection through a certain local network, or it can also be network-based through the internet, for example. That's how your disk can be connected to the server. So we have many of these type of networking. So the first type will be the direct attached storage. So this is what we call the DAS. So the DAS will be the direct attached storage. Guys, can you still see my screen? I don't know what's going on here. Like, screen is frozen.
Yes, sir, you can see.
Okay. It's not moving on my side. Okay, let's check. There must be some program taking more storage of my CPU, because this is really slow. Okay, let me try to go full screen. Okay, It should work. Yeah. All right. So we have the DAS, which is the direct attached network. So the direct attached network, this is just a networking type for storage. So basically, the storage devices are directly connected to a single server. So these are the storage devices. They are connected to a single server. So there is no connection between servers. You need to note that. With the DAS, there's no connection between servers. The connection is only found between the disk array, just maybe these 6 disks, and the server. And this can use a connection. For example, here it's using a SAS connection. We're going to see what is a SAS connection. And here we have a fiber channel in this case, and in this case we have a HCIA connection. So these are just 3 types of connection that we use in this DAS connection, in this DAS networking type. So these, you can either use the SAS connection or a fiber channel or a SCSI. All right, so you need to note the DAS, direct attached storage. So these, the storage devices are directly connected to a single server. So the connection is done through the SAS or fiber channel or the SCSI. Okay, some of the features of this connection is that it has a low cost. It's not going to cost you a lot to have this type of connection, but it has a high performance for the connected server. Okay, sometimes there's no network required because this connection can be done. It can be done directly, right, from the disk to the server, depending on how big this organization is. So obviously, you can see this is a case where we're going to have to use it in a small enterprise. So this is suitable for small application or single server deployment. So and then so this is a method that started from the 1970s, right? Where because of a data explosion, so we get to a point where a simple storage architecture, which we call the DAS, was then introduced, right? All right. So the link rate. Remember, we spoke about internet. So the link rate for this internet here, this connection, it can go from 3 gigabits per second, 6 gigabit or 12 gigabit, right? Um, those are some of the features. Okay, and then we have the NAS. Okay, so the NAS is the network attached storage. So this started in the early 90s, right? So this is basically where the storage are connected to the server over a network, all right? And this will provide a file level access. So basically, when we talk about through a network, it can be the Ethernet or a LAN, so wireless connection. So okay. So we have that. So some of the protocols that will be used here, which is the access mode. Okay, so basically we will have multiple front-end servers, right, that can use different operating system. All these multiple front-end systems, servers will share space in the back end, right? They will share space in the back end, so they are all using the same storage, but it's different servers, but they will be using the same storage. Okay, uh, so this connection, these protocols, or the access mode will be the NFS. So the NFS will be the access mode on that when we're dealing with Unix or Linux system. But when we but if we are using a Windows system, it's going to use the CIFS. All right, you need to know that. So the good thing about this network is that we have it accessible by multiple servers simultaneously. So multiple servers can access the data simultaneously. So everything is happening at the same time. So it's easy to actually share data, to share files and collaborate. Okay, so this is mostly used when we're talking about file storage. We're talking about shared media. Let's say you have organizations that are using the same media from one server or one database somewhere, and this will be the best network for that, the best network structure for that. So we will have many operating systems that can be implemented. As you've seen, Linux, you have Windows, they will actually all support this. Okay, so and then the third one will be the SAN. The SAN. This is the storage area network. Okay, so the storage area network is just a dedicated storage network that connects one or more network storage devices to the server. So what does it mean? So this will be a network that will just connect servers. So we have all the storage, we have the storage devices, and we have here the clients that are getting information from these servers. So through this fiber channel switch or the Ethernet, we can get access to this storage device. So basically, this is just a high-speed network connecting servers to a block level storage. So this is maybe a storage for this block. This is a storage for this other side. So we have all these servers here that are getting from different storage places, but the same client or the same users can access this side of the server and its storage, or access this side of the server. So this is a storage area network. So the connection is done through fiber channel, okay, or over maybe your IP network through the your internet, right? So the and then it provides all the storage as if it was just a local disk, okay, and it's known for having a very good performance. And this can be used in cases when we're dealing with big databases, virtual machines, and different application. Okay, so now sometimes we can combine a SAN, right? Sometimes we can combine a SAN for this because this work with the block. We can combine the SAN and the NAS. Okay, so we can combine them in the single system. So when we combine that, it's gonna support both the file and the block storage simultaneously. You see, this is the block storage, and then the NAS work with the file storage. So it's gonna combine both features. Okay, so those are the storage that we have. And obviously, when we talk about cloud storage, this is basically you are accessing a different storage, different servers on a certain network. Okay, so just for you to understand, first of all, the three that we started with. So when we talk about DAS network, that is more for local or single server. And then when you talk about the NAS will be for file sharing over the network. And then the SAN will be a block level storage for high performance. And then we can have a unified one, which is combining the NAS and the SAN. Okay, so now when we're looking at all these, they work through like all these fiber channels. So the fiber channels are just high-speed network technology that are used for this storage area network and all this. And it can go to a speed of 8 gigabits per second, or up to even 64 gigabits per second in other systems. Okay, so the type of connection that fiber channel use is what we call a fiber optic cables, right? You will see maybe some of you here, the internet that you have at your home, they will tell you this is fiber, right? So that's why you will see whenever you find someone with internet and then they tell you, no, this is fiber, you can see the internet is faster. than just having other type of internet. All right, so that is what we always hear. So the fiber channel, when we talk about the fiber channel, we're talking about a connection that is using the fiber optic cables. Okay, because when you use that, you have a very high reliability in terms of how the data are being transported through the network, right? And then you also have, so this is mostly used for enterprise databases, virtual machine. So fiber is the best internet to use. All right. So, so now we have all these type of connection that are very, very, very important. But sometimes you will hear about the what you call this. The okay, I was saying when you look at some NAS. Let me go back to NAS. It's something you need to get about NAS. Yeah. So in a NAS system here, remember we said we need to use, it's very important that you know that NFS, NFS means network file system. So the network file system is mainly used for Unix and Linux environment. Okay, so if you're dealing with Windows, remember you have the CIFS. All right, so the good thing about this system is that you have multiple users or multiple applications that can read and write the same files or the same directories at the same time. Okay, so those are some of the advantages there, and you need to know that this file system will be in the back end. So in the back end, that way we'll have a file system. So the file system will reside on the NAS device itself, okay, in the back end. And then the clients access the files over the network, but the management of the storage directories and the files is handled by the NAS device. Okay, so this is very, very, very important. Okay. And this is okay, and then we say the NAS will support a centralized management of scattered and independent data, facilitating access to various hosts and application. What does that mean? It means that when we're using the NAS here, the data, because when you think about certain challenges before you can use the NAS, certain challenges that you can have is that the data are often scattered across multiple servers or devices when you're dealing with big system. So each server will manage its own storage independently, which will make backup, sharing, or maintenance really difficult. But NAS will solve that problem by doing what we call, we say NAS will centralize scattered storage into a single system that multiple servers and hosts can access. So basically, instead of us having so many storages on different locations, but we can have multiple servers, but we have one storage. So we have kind of a unified view of files and directories that we have. So that's how NAS is going to solve that problem. So that will help you to simplify all the data management in terms of backup and all that. And it's also going to help in terms of collaboration across multiple servers and users, right? All right, so and then we have obviously the SAN that we just spoke about here. Okay, so we have the SAN, which we've described already. And then we will have, let's introduce the FC SAN. So basically the FC SAN is just the fiber fiber channel storage area network. So it's a storage network that use specifically the fiber channel, right? So this is a technology that was introduced in the middle or late 90s. This was just done to solve the poor scalability that was identified with DAS. Okay, so in this case, we can have more than 100 servers that can be connected to the network. Okay, so we can have more than 100 servers that can be, I don't know why the pen is not writing, that can be connected to the network. So with the fiber channel storage area network. So in this case, so what is that? So we have because we say why did it emerge? Because of the issues with the direct attached storage, which is the DAS. The DAS had a poor scalability. So there was a need for a way to network storage devices so that multiple servers could share the storage. Like in this case, we're telling you the FC-SAN allows over 100 servers to be connected to a single storage network. All right, so the connection mode that you're going to have in this case, we have the fiber channel. Obviously, we have the final fiber channel links, which will basically connect servers and storage devices. And then we also have fiber channel switch. So the fiber channel switch will just manage the traffic and enable all the multi-server connectivity, because we have multiple servers connected to the same storage system. So the fiber channel switch will be in charge of managing how the traffic is going to happen. In terms of the access mode, okay, in terms of the access mode, the storage space on the back-end device is divided into logical unit numbers, or LUN. Okay, and each logical unit numbers is assigned to a single front-end server for just exclusive access. So basically, all the back-end devices will be divided into unit numbers. So each unique number will be assigned to a single front-end server. Okay, so this is really gonna create a very high speed in terms of how to access your storage. And in terms of the link rate, so we can, common fibers channel speed will be from 2 gigabits per second, 4 gigabit per second, and 8 gigabit per second. But the modern FC-SANs can reach up to 16, 32, or even 64 gigabits per second. Right, so, okay, so it can also have like kind of advanced features which are can provide advanced data protection functions such as snapshot and disaster recovery. What does that mean? When we talk about snapshot, it means we can just have a point in time copy of data for backups and recovery. So basically, when you want to do your backup and recovery, we have like a certain point where we can still go back and recover certain data. And you also have a feature of disaster recovery, which means that it's kind of work as a remote replication to ensure that the data are always available. Okay, so about the fiber channel, you need to understand that this channel will really work well, because when we're using fiber, it uses fiber optic or copper cables, which means that when we talk about copper, that's why you see they use it even for electricity, because of the transfer of electrons. And you need to understand that data transfer is more like electricity. So copper works well as well when it comes to transferring data. So in short, you need to understand the FCSAN is just a high-speed dedicated storage network that is using fiber channel to connect servers to storage devices. Okay, so that is very important. So it's the same as the SAN, but this is more focused on using the what you call this, the fiber channels, right? So the next one would be this one that's supposed to be there. Yeah, the IP SAN. The IP SAN, this is the IP storage area network. Okay, so this is how do we call it again? So this is basically what we call does anyone know what does IP stand for? Does anyone know what does IP stand for?
Is it Internet Protocol?
Sorry.
Internet Protocol.
Internet Protocol.
Yes, that's correct. So basically, when we're talking about the IP storage area network, which is the IP SAN, so the Internet Protocol Storage Network, area network. I mean, so this is this will use what we call the ISCSI, right? So which is the Internet Small Computer System Interface, which will allow certain commands in order to transfer the information through your IP networks. You understand? So you have every computer that has an IP number, even the what you call this, your website. Any website has its own IP number. When you see you have 3 Ws, wherever, that is just for the browser to show that to the clients. But behind that website, there's an IP number that takes you straight to the to where your data are saved. So the IP SAN will use this technology, right, to just extend this SCSI protocol. So from a local storage to a network storage over the Ethernet. Okay, so this technology is introduced around 2001. This is designed to address the cost and management issues of fiber channel SANs. So because of the cost of your FC SAN, that's why this was introduced in 2001, when another technology could actually works in terms with a connection mode of the Ethernet link or Ethernet switch instead of using fiber links and fiber switch. So remember, the Ethernet links connect servers to the storage devices, and then the Ethernet switches manage the network traffic. In terms of the access mode, so the storage space on the back end devices will also be divided into logical units numbers. So each logical unit number is assigned a single front-end server, which will provide a block level storage. So this is exactly what the SAN. And in terms of the link rate, so we can go from 1 gigabit per second to 10 gigabit per second. Okay, but depending on what we have now with the modern Ethernet standards, we can even go up to 25, 40 to 100 gigabits per second. All right, so you can see it even nowadays. You can find someone showing you the internet, they can go up to 100 gigabits per second. without even using fiber. Okay, so that is what we have for the IP SAN. So if we have to compare this, so we basically have to compare them through the transmission mode, the data type that they are using, the application scenario, the advantages and disadvantages of it. So basically, this table gives you kind of a summary of what you actually have. For example, you have the DAS here, the transmission mode. It used the SCCI, it used fiber, and it used SAS. NAS will use the IP. FC SAN will use fiber. IP SAN will use the IP. So those are how you compare them. Okay. All right. So the next thing will be the storage form. Okay. So in terms of the storage form, we have different storage form. We have a centralized storage form, distributed. All right. So when we're looking at the centralized storage, so when we're talking about centralized storage, so basically we are talking about a centralized storage system. What we mean by that is we have a single storage system which will be composed of multiple storage devices which are kept in a centralized environment. Okay, so this is what we see, for example, in all the data center that are used by many big companies. So a centralized storage, we just refer to one of the sets of storage system, which consists of multiple devices. Okay, so you'll understand that a lot of enterprises will often deploy their storage devices on a centralized environment. Okay, so for example, we have the Huawei storage system, right, which often use several cabinets to house multiple storage devices, all managed as one system. So you have multiple devices, but they're all managed as one system. So this can include like the SAN or the fiber channel SAN, which is the FC SAN, or IP SAN, or even NAS storage. Okay, so some key features of this is just it's really simple to deploy. You have a simple deployment here. So this is an example here. We have multiple servers. They are all through the Ethernet switch or the IP link. They are all using the same. They are all using disk storage. Okay, so which are kept as one unit. Okay, so you have simple deployment. So unlike some distributed storage, you don't really need to worry about collaboration between servers. And then you have centralized management because all storage devices are managed as a single logical system. So there's one system that is controlling all these storages. Okay, and this will help to simplify like the administration, monitoring of how the system is behaving, backup of data. You want to back up the data. We know that all these data are kept in the same place, and remember, we're using one system that is controlling all these devices, and you can easily, like the scalability will be very easy. You can scale easily and grow your enterprises because we can have additional storage devices that we can add to a centralized system to just increase the capacity and the performance. So we can add more devices as well to this storage here, right? So we can add more storage if you want to grow. Okay, so the type of centralized storage that we can have, we have, for example, the storage area network, which is the SAN, which is a block level access. So we can use an FC SAN or IP SAN. And then the second one is with the NAS. So the NAS can also be considered to be a centralized storage. Why? Because it's also a file level access for sharing and collaboration. So when you look at the NAS network, we can collaborate between that for what you call it, for the file sharing. So as we've mentioned, so the advantages, it's easy to deploy and manage. It can also provide a single point of control for all the storage. So that means that one system can control how everything is behaving. So this is really ideal for data centers because of the performance, and we can actually have a centralized management and manage all these servers and storages. So those are some of the advantages. But again, there is also a few disadvantages of that, because some of the disadvantage of that is that sometimes the storage devices are connected to only a limited numbers of servers, which can be done via a certain dedicated network. So now, if you have a system that is centralized, but there is a group of data storage that do not have access to all the servers for whatever reason, so that will limit the accessibility of data, depending on where you need the data from. Okay. So another disadvantage of a centralized storage is when you keep on expanding the capacity by adding more disk to a single controller. You have a single storage controller here, and then you keep adding more devices. You're gonna hit a level where you're gonna have what we call an hardware controller bottleneck, where now the storage controller is going to be confused because there is so many devices, and the capacity may not be may have been more than what we expected, and this can create a problem. You understand? This can create a problem with all the data that we have. So and another disadvantage can be if you're dealing with this type of application. You can only work with it if it has to work with one enterprise, because if you have a system like this, you can't share between multiple enterprises, because now this system, it means that one server has access to everything that is happening here. So you can't have multiple companies using this architecture, because they will have access to other people's data. And that means that now your system has to be limited. So you can't create a big system which you can resell to people for using your system as a cloud service. So you can't create it as a cloud service. So if you want to create a cloud service which you're going to provide to clients, you can't create a centralized storage. You can create it by using this architecture here. All right, so those are some of the information that we can get. So in short, you need to understand a centralized storage is just a simple storage system, right? Which is created just to increase the performance and the scalability, right? So this system means that we have multiple servers that are connected to a certain group of disk storage, which are controlled by one system. All right, that is just for a good management. All right, guys. So this will be all for today. Any question, comments before we can call it a day? In the meantime, you can just turn on your camera so we can get an attendance screenshot. Any questions, guys? Any questions? Any questions? Guys, anyway, regarding the mock exam for